The Egyptians would measure things using their hands, sometimes with their thumb, sometimes without their thumb. But now, in modern times, thank goodness, we can use something like tape measures, a little bit more accurate and very, very standardized. But even that is not the bleeding edge of our measurement. Today we're going to use the CubeSat by Ardusat to measure, luminosity, among other things. Check this out. Today I brought with me my two lasers, my blue laser and my green laser. There's the first one. Haha. So we're going to measure the luminosity coming off my laser. Okay, you ready? Here we go. I'm going to point the laser at the luminosity sensor to see what it does. Oh, but before I do, we need to measure it. We need to make this scientific. So we're going to step back, technologically speaking, and just use a length of string. Why? Because everybody has string, and you can do this at home very easily. So I'm going to take my string, I'm going to fold it in half, and I'm going to hold it to where the sensor is down there, and that point in space. And I'm going to memorize that point in space. I'm going to point the laser from this distance. It's about 6 inches, and let's see what the luminosity sensor does. Bam. Woo! Look at that. Now, I've done this before, so I can tell you right now that we just peaked that. It's at 60,000. That's awesome. And the reason it's fluctuating is because my hand is fluctuating. But now, we're going to change that. We're going to take the string and use the full distance, which is just over a foot, so about that distance, and let's see if the luminosity changes. My theory is that it won't, because laser light is all the frequencies of one particular color in unison. My little theory is that it shouldn't change the luminosity, and we can see by the data right there on the screen that it's not. It's still pegging at 60,000. Now we're going to do something a little interesting. I'm going to change the aperture of the laser, and instead of having a nice fine point, it's going to be a nice wide point, like that. So we'll go back with the string, half the distance again, and try it. Right there, here we go. What do you think is going to happen? Oh, look at that. It looks dimmer to my eyes because the light is spread out, but the sensor also gets that as well. It definitely is dimmer from a luminosity standpoint. Let's back it up. I think we already know what's going to happen. Should be even dimmer still. There's the data to show it, right there. So now let's do this. Let's bring it 4 times as closer. So the string goes in half, and then it goes in half again. Let's hold it. What do you think is going to happen? Do you think it's going to peg at 60,000? Okay, so that's about 3 inches away. Here we go. Let's see what it does. And just as we expected, it was higher, but look, it still didn't peg at 60,000. So now, we're going to change lasers. We're going to go and use the green one. See what the green one does. So, do you think the green one's going to be brighter, dimmer, or about the same as the blue laser? Well, let's try it and see. Let's do a 12-inch distance. Right there. 1, 2, 3. If I can hold the laser still, we'll actually get some really good data on this. There it did. Pegged at 60,000 again. Cool. Green lasers are actually a lot harder to look at than the blue ones. I know because my wife and kids tell me that all the time. Like, stop playing with the laser, Dad! They're actually really cool to play with, and now using the CubeSat, we've actually got data to demonstrate that. But we're not done. Check this out. Right next to the luminosity sensor is a UV sensor. So if you're going to look at the UV square on that, watch and see how much UV light is coming off the green laser. Distance doesn't matter on this one as much. But let's see what it does. Not much UV light coming off the green laser. Let's see how much UV light is coming off the purple laser. Now, if you know anything about light, you will understand that ultraviolet is a higher frequency. Blue light is a higher frequency than green. So we should see more UV light coming off the blue laser. Ready? 1, 2, 3. And we do. There it is. Zoom in a little more because I've got it on the wideband. A lot more UV radiation, which means that if we were to hold this on our skin like this, we could get a sunburn from that's actually getting kind of warm, from a laser. It's science.